To this webinar on the SILStat software. My name is Iwan van Beurden. Audio is provided through our speakers. You should be able to hear me just fine right now. Everybody here is muted. If you have a question on the right-hand side, you can ask questions, and I will see those, and I will address those as they show up. So thank you for attending this webinar on collecting field data using the exida SILStat software. And SILStat is our live event recording and monitoring software. I'll go through a short presentation, and then based on time, we will switch over to the actual SILStat software, and I will use that to demo some of its capabilities. As I said, my name is Iwan van Beurden. I'm the Director of Product Development at exida, and I support exida end-user services and manufacturing services, as well as I do some of the certification activities. I am responsible for the development and maintenance of our end-user software, where SILStat is one of the tools that falls under that responsibility, as well as the Excellencia software that some of you may be familiar with. So, what are we going to talk about? Problems that people have in general in the industry when it comes to implementing functional safety, and not in the analysis and realization phases, but in the operational phase. What do we need to do, and how do we need to do that? Then I'll introduce SILStat version 2, and we actually released the version 2.1 earlier this week, yesterday to be precise, and there's some improvements again and additional functionality that we added to the tool. I'll talk about how the tool works, and then end with how we record events. So what are typical problems that users have when they implement the functional safety lifecycle? Well, first of all, if we look at the standards, there isn't that much emphasis on the operational phase. We see, now if you look at the life cycle, we see, let's say in the 61508, we have 16 boxes. And of those 16 boxes, 1 or 2 relate to operations, and the rest is all analysis and realization. So there's a lot of emphasis on doing your process hazard analysis, doing your SIL selection, your layer protection analysis, doing your SIL verification, developing the system, building it, planning, and all, do all the important things. But then when we get to the operational phase, there isn't a whole lot, there isn't a whole lot in the standards to say, hey, you need to do this or that. Now, one of the things that we do need to do is we need to demonstrate compliance to the conceptual design. So, during the SIL verification, what did we do? We came up with a safety instrumental function that is protecting against a certain hazard. Well, that hazard is something we identified during the PHA, and has a certain level of risk. And we need to reduce that risk to a tolerable level. And in order to do so, we came up with a safety instrumental function. And that safety instrumental function could be, let's say, a high-pressure protection sieve. And as part of that design, we may have assumed certain equipment, we may have assumed certain levels of redundancy, but one of the parameters that we've assumed is a certain proof test interval. So we may have said, well, we need to test the sensors or transmitters once every 5 years. We need to test the logic solver once every 5 years, but maybe the valves once every year. But let's say we have a toxic gas detector. The toxic gas detector may be something that only needs to be proof tested once every 5 years, but it has a sensing module that needs to be replaced once every 3 months. So in order for that conceptual design to be valid, in order for us to be compliant to that conceptual design, we need to do these tests and any maintenance activities that are required. We also need to record failures. So that's one of the things that the standards talk about. We need to record failures, and we need to record demands. Or maybe even better, we need to record the frequency at which initiating events occur. And why do we need to record those information? Well, first of all, we need to see if there's anything that we missed during our analysis and realization work. But we also need to be able to compare our assumed rates of failures to the actual rates of failures, and assumed frequencies of events to the actual frequency of events. So when we talk about demonstrating compliance to the standard, in order to be compliant with 61511, it's mandatory to record proof test results. It's mandatory to record field failures and demands and analyze those. So it's if you want to demonstrate that you are compliant with NCISA 84.0.01-2004, then this is what you need to do. If you want to be compliant to API recommended practice 754, that requires that we record performance indicators. Process safety performance indicators for refining and petrochemical industries is what this recommended practice is about. So there's a couple of guidelines and standards in the industry that require us to record this information. And apart from that, it's just in general, it's of course good practice to look at this information. I may not have average industry information. And one of the things that we've seen when we've done field failure studies is that in some cases the probability of failure for a relief device is not once every 100 years on average. No, it may be a whole lot more frequent. It may be based on the location in the plant that a device is used. Also, during SIL verification, we use an average worst case environment estimated failure rate. The predictive analytics that exida uses, for example, when we do 61508 assessments on products, will predict an average worst case environment failure rate. But that average worst case environment failure rate may not be applicable to your particular site. You may be worse off than that, or maybe you're better. You need less functional safety than anybody else. So when we look at the standard, one of the things that we need to do is we need to compare actual performance with assumed performance. Why is that important? Well, we assume certain level of risk reduction achieved, and we may not necessarily have that level of risk reduction achieved if the frequency of demands is too high, or our assumed, or our rates of failure are much higher than we expect. So one of the things that may happen when we compare actual data to assumed data, so we may come to the conclusion that we're spot on. In which case, just continue collecting data. Apparently, your risk reduction is right where it was, where it needed to be. In other cases, you may come to the conclusion that the risk reduction is not enough. The risk may be higher. Maybe there's a higher frequency of events than you originally assumed, or maybe the safety instrument function is not as effective as you thought it would be. The failure rates of the equipment is higher than you expected. If that's the case, then you may need to go back to the analysis phase or a realization phase and redesign and re-implement. The other scenario, which one would expect in the majority of cases to be applicable if you use average worst case failure rates, is that your actual system is over-designed to prevent against a specific hazard. You may actually have more risk reduction than you needed. Now, I'm typically not suggesting to start changing designs of existing systems, but this is information that you can use in the future when you redo your layer protection analysis, or do a new layer protection analysis, or a new SIL verification. So in the future, there may be potential for cost savings just by extending proof test intervals maybe. So there's a lot of information to be gained out of the data comparison. How are we doing compared to what we predicted? And do we have enough risk reduction? Do we need more risk reduction? So what data should be collected? This is just simply saying, hey, we collect data, is that enough? And what will we do with the data? And if we don't record any failures for a particular transmitter during the first year, does that really mean that the failure rate is 0? Or how are we recording data? How do we compare to others in the industry? Is our maintenance culture and safety culture, is it comparable? And these are things that maybe not that trivial initially, but when you start to look at different ways to record information, you may real quickly find that there's huge differences from one side to another, even within the same company. Why do we need to collect data? Which is just sometimes a huge challenge to communicate to operation maintenance people. Say, hey, yes, I realize that just simply resetting that transmitter, powering it up, powering it down, or the other way around, powering it down, powering it up, that solves the problem, but you really need to record that piece of information because that could be an indication of a serious problem with that transmitter. And not everybody may be aware of that particular scenario. So, all right, so let's look at SILStat. What is SILStat? Well, it is a tool that we've developed at exida to capture key operational and maintenance data, such as equipment failures, process demands, success or failure, protection layers, proof test results, execution of mandatory maintenance activities, etc. And that's allows you to review your actual data with assumed data as required by the functional safety standards, and allows you to be in compliance with mechanical integrity programs such as the OSHA PSM program. And it's a tool that has been on the market for quite a while. We've had some pilot projects with our first version of the software, and we've learned from those obviously, and we've improved the second version of the software quite a bit, and it's being used at different locations around the world, and that's it's exciting because there's a lot of data that is being collected. But at the same time, it also allows our customers to demonstrate how they are compliant with the standards. So not just from a, I'm collecting data, but also from a, hey, we are doing these mandatory proof tests and maintenance activities just as we assumed in our conceptual design. So one of the things that we do in addition to just simply selling the software is with your annual maintenance, we offer a data analysis and review, and that allows us to compare how you collect your data with others in the industry. We may be able to simply flag, hey, you guys are doing a couple of things a little bit different than others. Maybe you're not as consistent, or maybe you're doing a better job than others in the industry, and we need to inform everybody else that they need to step up their game. But that gives you some overview. But we will also help you evaluate the data, because when we talk about failure rates for safety instrumented systems, what we really are looking at are failure rates for random hardware failures, and we need to distinguish between failure rates for random hardware failures of equipment and systematic failures, and we also need to look at what are product-specific failure rates and site-specific failure rates. So in the past, we've done some analysis work, and we saw that for the exact same product, from one side to another, the probability of failure could change, and the failure rate could change by a factor of 2, just because there's a different maintenance culture in one side versus the other side. So that is an area where where this annual review can be quite effective. And also another thing, the tools can all calculate failure rates, but when it comes to those those failure rates, we really need to wonder if those failure rates are effectively representing your actual performance. If there really is no failure, does that mean that your failure rate is 0? If you had 2 failures, does that mean that your failure rate, let's say in 1 year, is that on average you have a failure once every 6 months? Or are these systematic issues? Or are you using the product in an environment that is not, that the product is not designed for? So those are things that we look at when we do this analysis and review work. All of this is done with the simple objective to find problem areas. We are doing this detailed analysis to find problems that are related to specific locations in the fields. We are doing it to find issues that are related to specific devices. And we are looking at this to find issues that are related to specific device types. So what are device types? A device type is a specific type of equipment, which could be, let's say, if we talk about pressure transmitters, it could be a Rosemount 3051C transmitter, or a Yokogawa EJX, or a Honeywell ST3000, and so on. And obviously there are many more pressure transmitters. That could be a specific type. And you may be able to find that a particular type of transmitter just doesn't work at your site. And we've talked with many end-user customers, and we've seen with some that on one side, manufacturer acts as the preferred vendor. On the second side, they're on the blacklist. Don't buy from this manufacturer, and it's similar use, but on one side, there's just something that's a little bit different that makes this transmitter not operate the way that everybody is expecting it. So it will allow you to identify issues that are specific to a device type, but also to specific device. So let's say a transmitter failed or a valve failed. Let's say a valve failed, and I take that valve out of service, I send it to a valve body shop, gets it repaired, I get it back, put it back in service, maybe at a different location. But if it fails again, I can track that particular device. Or if it's on a specific location, if I replace it with a different valve, and the valve fails at that specific location, maybe a location-specific problem that I can identify this way. So why do we do this? Well, yes, we need to record data. We need to compare data to our actual data to our assumed. But the real benefit is that if we find problem spots, we can reduce fault strips, and thereby increasing our uptime. Now, when we collect this data, we will have data for future safety lifecycle tests. So whenever we get in the future, we need to do another risk assessment, we may have the data available for that. Or when we need to do a layer of protection analysis, we may have probability failure information for our protection layers and so on. So the collection of this data may help in justifying lowering failure rates, extending proof-test intervals, or justifying the selection of a particular protection layer with a certain probability of failure and so on. So that's another area where this information is very useful. Now, one of the things that you need to consider and take into consideration when you are calculating failure rates, if you just have a few data points, your estimates will be all over the place. Your confidence intervals will be very, very broad, simply because there's not enough data points. The more data points you get, the narrower your confidence limits will be. And the closer you will be to an actual failure rate versus a wide range of potential failure rates. So by combining data from multiple sites, you may be able to achieve that. At the same time, if you have just one site, but exida will review your data and evaluate, that may be another data point that we can add to say, hey, you experienced one failure with this particular device. All the other customers experience many more failures with that particular device, so your failure rate may be lower, and so on. If we look within the safety lifecycle, then some of you are already familiar with our Excellencia software. Our Excellencia software covers the analysis phase and the realization phase. We have our process hazard analysis tool, we have a layer protection analysis tool, we have our SIL alarm tool, select, process as arrest, design as arrest, we have a silver tool, alarm rationalization already mentioned. All that is analysis and realization related. When it comes to the operation, that information can be used, but that's where the SILStat tool comes into play. It's a separate product that will use the information out of the Excellencia tool, but that's going to be running continuously, whereas Excellencia is really a project-based tool. So that's how our items fit within the life cycle and what the SILStat tool does. So how does the tool work? Well, just from a terminology perspective, we have a couple of items that are worth mentioning. We talk about devices, which is a unique equipment item with a unique serial number, which could be imported from Excellencia, either the Select or the Silver tool. Select would account for the IPLs, Silver would account for the information in the safety instrument function. We talk about addresses, which are the physical locations of a device. So in a address, device X may be located, but when device X gets replaced, device Y takes over that address location. We keep track of that particular location and that particular device X as it moves around the plant. And then we talk about hazard scenarios, which take into consideration all the protection layers that will protect against a certain hazardous event and the sequence in which they will protect. And a lot of this information can be imported out of Excellencia. Sure, there's always some manual configuration that needs to be done, but you can just simply take an Excellencia project and I'd say import it in SILStat, and you can start collecting data. And of course, you will not be recording failure events right from the start, but it is a ready-to-go system. You don't really have years and years of setup that is needed. It is ready to go out of the box. And then here's just some examples how we can import stuff out of Excellencia. Just simply say import an Excellencia project. And then this is an example of a thermal oxidizer unit that just simply imports that information into the project or into the SILStat file. So when we talk about hazard scenarios, by knowing the different independent protection layers that are protecting against a certain hazardous scenario, we can, and by knowing the order in which they execute, we will be able to know when we record the success of an IPL automatically if IPLs were exercised and if IPLs failed. So for example, if I have a control function, a safety function, and a relief valve, and if I say that the safety function was successful, I automatically know that the control function failed. And I also know that the relief valve wasn't exercised. Now, we keep track of that, so whenever there's an initiating event, you can record that. Which one was successful, which not. And the interesting part here is that this will help in the overall discussion as to what is the demand rate on the safety instrument function. Because quite often I see people wanting to argue that safety instrument functions are either high demand or continuous mode for 61511 because the initiating event happens once every year. Well, the initiating event may be happening once every year, maybe even more frequent than that. But usually, in the process industry, we see there's protection layers in place, like a control function that will protect against the initiating event, an operator that will protect against the initiating event and the failure of the control function, and so on. So there may be multiple layers of protection that act before the safety instrument function is asked to perform its function. So with that, the actual demand frequency of on the safety instrument function may not be once every year, but maybe once every 100 years, assuming there's a probability of failure for the control function and the operator of 0.1. So that's why in our Excellencia software we default to low demand applications or demand mode per 61511 simply because that's what we typically see in the industry. So, but this will, recording which IPL was successful, which one was not exercised, will help in that discussion. So, and here is that example where a hazard scenario could be high main fuel pressure. I have a couple of protection layers, a control function, a SIF, and a pressure relief valve, and the control function, consists of a couple of equipment items. The safety instrument function consists of a couple of equipment items, and then the relief valve. and I would be able to document which one was effective against, which one was effective in protecting against a particular event, and which one was not. And then let's say the safety instrument function was successful, that means the control function fails. I can then record which component within the control function was the failing component. Was it the control valve? Was it the transmitter? And here is that same scenario as it would look like in a hazard scenario editor in SILStat. In SILStat, we have an advanced proof test generator, and what we mean with that is we can set up a proof test not by a descriptive set of steps that need to be executed. No, we can set up a proof test with specific steps where each step has a pass-fail criteria. And when a end user, or when the maintenance person is performing the proof test, they can then record the factual data. They will not have to conclude if a proof test passes or failed. They simply have to record the factual data, and that will help in the later root cause analysis in case something does fail. And here's an example of a screenshot of a proof test generator. Use a hard communicator to drive the output to 21.5, and you expect 21.5 with a certain tolerance. Then hard communicator to 3.75, you expect 3.75 with a certain tolerance, and so on. And then when you record the proof test, you record the actual data, the tool will automatically determine if you pass or fail. And that's what we're going to look at now. So there's some setup, some configuration items, but then once that is done, we can actually start recording events. So here's your proof test. You identify the address that the proof test must be performed on, and then the steps will show up, and you'll have the ability to record factual data. So here we have that 21.5 and 3.75 are the areas that we want to drive the output to. We record those pieces of information, and the tool will say, hey, that's within tolerance, or that's outside the tolerance. So the screenshot in the back, the hard communicator drive the output to 3.75 milliamps. The result is 3.89 milliamps, and that's outside the 0.1 tolerance that we allowed. And in the screenshot at the lower right-hand corner, we have a 3.79 that is within the tolerance. So in that case, the proof test passes. So based on the actual data that we record, we may come to the conclusion that we meet, that the proof test is passed or not. Then we have maintenance events, so we can record maintenance events. We identify the device that maintenance needs to be performed on, and then we record the type of maintenance. What's the S found and S left condition, and what type of maintenance did we do? Did we just do a repair? Did we do a reset? Did we do a calibration, and so on? So those are the types of maintenance tasks that we can record. And then one of the things that I forgot in this slide set is maintenance activity. So I already mentioned the sensing element in the toxic gas detector. We could have a maintenance activity scheduled every 3 months, replace that sensing module. So that's also something that you want to keep track of and that you want to perform in order to make sure that you comply to your original conceptual design. So when it comes to process demand recording, you record which IPL is successful, thereby automatically identifying which one failed. And that's what we see here. We have a process control loop with SIF. We have a pressure relief valve, and in the upper left screenshot, the tool failed. The control loop was successful. In the lower right hand, the control function apparently failed. The SIF apparently failed, and it was the pressure relief valve that was successful. That is the one that is green, and then I can identify which component in the SIF and the basic process control function, which ones failed. I can look at the events. I can see all the events. There's filter capabilities on top of the events, so I can look, for example, all the proof tests for a particular device. We have some reporting capabilities, and most of the reports revolve around maintenance activities and proof tests right now. And what are we looking at? We are looking at proof tests that are about due, and are looking at proof tests that are overdue, and we look at a generic SIF status report. So how are my safety instrument functions doing? Did I do all my maintenance tasks? Did I do all my proof tests and so on? We do have reporting on failure rates, etc., but we've currently disabled those simply because you need a lot of information before you start concluding what the failure rates are, simply because if you have one event in 1 year, does that really mean that the failure rate is once every year or not? So before people start to make conclusions, we kind of said, let's disable this feature for now, just so to make sure that when we review the data offsite by exida, that we get failure rates that are actually realistic and usable in SIL selection and SIL verification. There's a dashboard which shows the proof tests that are due and the maintenance activities that are due or overdue. There's configuration options as to what percentage overdue you would want to consider, or how many total functions you want to consider in your statistics. There's some address statistics as well, showing how many addresses there are per particular unit in your configuration, as well as how many addresses have a device assigned to them. So you would expect that is a one-to-one, basically. But if there's any empty addresses, there's a error checking going on. And then your most recent demand and failure rate estimates, those are things that will show on those dashboards as well. So in summary, now we need to record functional safety related statistics. And, there's no way around it. We need to record that information, and we need to compare that to our assumed performance. And we look at the demands or initiating events. We look at proof tests that need to be performed, and results need to be recorded. The same thing with these mandatory maintenance activities. Replace your sensor module, or you could even consider a partial stroke test, a maintenance activity that needs to be performed and that you need to record. And obviously failures. If there are any failures, we want to record that as well. One of the things, SILStat version 2, we've learned a lot from our version 1. Why do you want to do this? You want to be able to demonstrate compliance to the standard. You want to find problem areas and improve your overall plan redundancy. There's a lot of easy system configuration by importing out of Excellencia or even custom CSV import capabilities. We have very limited open functionality import because every customer is different, and instead of making assumptions and then not that the customer's installation is just a little bit different and the assumptions are not valid, and then having an inadequate import, we typically work together with the end user to get a specific import for that end user, so we know what the assumptions are. The end user knows what the assumptions are that he made or she made, and we can use that. And within our development environment, there's a lot of flexibility, and we can import information. And usually, it's something you do once or twice, so it's much easier to assist with that than trying to do this on a generic level where everybody can import everything, and then 9 out of 10 times there's one thing that's just a little bit different, and it doesn't really satisfy the customer. So that's why we have a more hands-on development environment import for anything that's not Excellencia specific. All right, so I assume everybody's familiar with exida. We are multiple locations around the world, and I assume that you are familiar with our products, but I just included these slides for reference, as we will be handing out the slides, or at least the PDF of the slides at the end of the webinar. So if there are any questions, feel free to ask. If not, I'm going to go into the tool and do a little demo of the tool itself. One thing that came up during our first session this morning was a question on capabilities of interfacing with other platforms. And some of you may know of our alarm rationalization software, SILAlarm, where we can cooperate with manufacturers' DCS system, and we can use those systems we can use the alarm rationalization software to help write information on nameplates for alarms, and interface import-export with those DCS systems. We're looking at similar integration with some of the let's say asset management type recording systems, where if events occur, that we are automatically feeding those into Excellencia, into SILStat, so that we can evaluate that, and that the user doesn't have to manually ensure to put that in. Questions can be asked in the question pane, and here's a good question, and that that question kind of relates to the acceptance of recording this type of information. And the question is, do you have an estimate of amount of time that is required to feed information in SILStat on a per CIF basis, on a per CIF per year basis? And now the answer is, I don't know. And the reason I don't know is because it all depends on the amount of activities that are related to that particular safety instrument function. If I have a CIF where I only need to perform a proof test once every 5 years on all parts of the safety function, then the first 4 years I'm not filling in any information unless there's a failure. If I do a proof test, let's say twice a year, then obviously I will be recording that proof test information, and then you have to do the actual proof test and the recording, but you need to record the results of your proof test anyway. So if the proof test will take half an hour, then maybe the actual recording as you go along, and the SILStat tool will provide you the steps of the proof test, may add an extra couple of minutes, but it only adds those couple of minutes if you don't record your information otherwise. If you are recording your information, then there's no extra time needed. Yes, if there's failures, there's going to be extra time. So how do you record events such as PSV failure if it's not recorded on the DCS? Well, that is, right now, a lot of that information would need to be recorded manually. So when you have events that are not tracked by the DCS, then obviously you will need to record that manually, and yeah, you can, but there is the extra effort at that point that is needed. Now again, you need to record that information anyway. SILStat provides you a framework to do that, and provides you a framework to eventually compare that to your assumed failures, and also eventually, it's something that we will be working on in the next. In one of the next iterations, feed information back from SILStat to your SIL selection and SIL verification. Let's see, a couple more questions. It's good. So here's a question: does the software provide average failure rates? I'd say no. The SILStat software doesn't provide average failure rates. The SILStat software is linked to the Excellencia software, and the Excellencia software has all this failure rate information. So the Excellencia software has failure rates for all these specific transmitters and industry average transmitters, and that's where the comparison we take. Now, as part of the exida annual evaluation of your information, yes, we will put in a comparison to this is what average industry data is, and this is what you are seeing, but it's not within the tool itself. That comparison is done outside. And this, yeah, someone here, an excellent point. Let me explain what the excellent point is before. The statement is, you are aware that field data is notoriously under-recorded or not recorded on a scheduled basis, which is absolutely true. If a maintenance person, and there's nothing wrong with that particular person, if he or she can just simply reset a transmitter and it's back up and running and everything is fine, That's probably what's going to happen instead of actually going in and recording information. The only way we can force people to record is by explaining and that this is important information that needs to be recorded. That, you know, it will affect their exposure to a certain level of risk. Because if that transmitter fails on a very regular basis and you don't record it, everybody assumes it's a perfect transmitter. In reality, you may be exposed to a level of risk simply because your safety instrument function is not working. Now that's another. You know, how do we help people in recording this information? Well, I'm going to open the tool in just a bit, and one thing I should say is we have. What I will show is what we call SILStat Lite. It's something that you install on your local machine. We also have a SILStat Site version where we have dedicated recorders where you only have recording capability. One of the items we're looking at there is to create the ability to have that on an iPad type handheld device. So it is something that people take with them out in the field. Now, one thing that I should emphasize as well is, like, okay, we've named this product SILStat, and the reason why we want to record this information is because of functional safety standard compliance. However, it is not limited to functional safety standards only. A pressure relief valve is considered another means of risk reduction not covered by IEC 61511. It's obviously, I think everybody agrees, very important to cover that particular information to evaluate if your performance is as you expected, even though it's not covered under the standard. So you know, you can extend the use of SILStat to beyond just safety instrument functions. You know, they may not have a proof test per se, but you would be able to record any additional actions that need to take place, or just if something fails. And you can include control you know, equipment in addition to the safety equipment as well. So here's another question. Does the tool have built-in failure modes and failure codes pre-populated per instrument database to track them properly? And yes, that is something that I'm not sure if that's on my version of the tool. I tend to not run the official released versions of the tool, as I tend to be involved in some of the earlier testing. But yes, that's the intent. As soon as something goes wrong, you flag it, and you will be able to you know, indicate what failure mode it is, what failure code it is, and it's the setup is kind of intended to be on a hierarchy level, so that, hey, it failed, and that's just the only thing you record, or hey, it failed and the output went over range, or hey, it failed, the output went over range, and this is the error code. So, you know, depending on how much information you can or have, you can go into more detail. Okay, another question: can you use SILStat as a standalone tool, or is Excellentia required? No, SILStat is a standalone product. It's an operational tool that is independent of Excellentia. If you use Excellentia, the setup is a whole lot easier than if you don't. The setup is not that difficult, but you know, there's less manual work needed. But it is a standalone product from that perspective. All right, so let me try and launch our SILStat software, here we go. Oh, it's behind the presentation probably, or behind this window that I have here. Yep, there we go. So I'm going to connect to the server, and there we go. Here is SILStat. And one of the things you'll notice is my dashboard is rather empty. There's not a whole lot of stuff on here, and the reason for that is that I had a lot of customer proprietary stuff in there, and it was really time for me to clean up. And as a result, I'm stuck with a kind of an empty database. But just to show a couple of things, you know, we have our overall configuration where some of the things are like equipment type editor. The equipment types are based on the CCPS PERT initiative, the Center for Chemical Process Safety, Process Equipment Reliability Database initiative. And we have a device model editor. The device model editor allows you to specify all the different types of equipment. And here you see a bunch of different types of equipment that we have defined for, or within our Excellencia database, or I should say the Safety Equipment Reliability Handbook database. You see equipment type. There are some, let's say I only want to see pressure devices. There's filter capabilities. And here you will see all the pressure transmitters. So where I named a couple before, this is everything that we have specific failure rates for, and that we could link to a particular device. So in the plant settings, we go to the plant hierarchy. I have a hierarchy here where I have the U.S., I have Philadelphia as a location, and a thermal oxidizer as a unit, or a plant with an incinerator as a unit underneath. And here are all the addresses within that plant. And I'm going to pick this first one, PIT 07269-sense, and I can link this to a particular device in our database, and you'll see that this Roseman 3051T1235 is a specific item. We'll see that in just a bit. I've linked this to a proof test, and we'll see that one in a little bit. I see what the proof test interval is, and I ran this test this morning, and that's why the due date, I had it scheduled for tomorrow, but let's say that I actually used this. My proof test was due yesterday, the 15th. So I went in and manipulated this. Whenever I update, when I do a proof test, it will automatically set the next proof test due date. I can set up assigned maintenance activities. I haven't defined any in this particular database, so I cannot link to one. But you can set up if it's a one-time issue, if it's a periodic activity. And one of the maintenance activities could be replacement of equipment at the end of useful life. I can include documents, I can include pictures, and so on. So let's go back to our dashboard real quick, and one of the things that we see is, hey, there's a proof test, just one at this point, one that is due. Yeah, actually it was due yesterday, but I can make some changes to this. Let's say for the next couple of months. Actually, that means it skips it skips the one from yesterday. But let's see if I go to 15 months or so. It shows that there's a test due in February, and the one that is due yesterday, actually there are two tests due in February. The one that's due yesterday just falls off this chart. But in the overdue, you'll see that, hey, there's one that's overdue. So this is a gauge that will tell you, hey, this is the stuff that you need to look at. All right, so plant settings. We talked about the hierarchy where we have all our addresses. We have devices. So for example, this particular transmitter, and I'm not sure if I have a filter on right now, but this particular transmitter, I can link it to a device model, and that device model is here we go, a particular Roseman transmitter. And I'm just randomly picking something. It has a basis for useful life. And when I imported this out of Excellencia, so let me see, when I imported this out of Excellencia, I just set Roseman 3051T. I added manually the 1235 as the serial number. I realized that's not the standard serial number that they use. But same thing. I could use I could have picked a Honeywell transmitter. What I'm doing here with this device name is I'm making it unique. So if I would, for example, click on this one, a generic high-performance butterfly valve, that doesn't really tell me which device that is. So I would want to make that unique, and I can do that by adding the serial number in the device. Let's go back here. Where are we? Here we go. Now you see the useful life. After 50 years, you need to replace this. This is the basis for it. This is the install date. So when was it installed? When did surveillance start? So this transmitter, and I don't know when this one was released, but let's say this was installed 10 years ago. I want to record that because after 40 years from now, after 50 years from the original install, we reached end of useful life. But the surveillance date is the date that I'm starting to use SILStat. So that will be the amount of time that I can take into consideration in my operational hours of experience. And then they're taken out of services when I remove this and basically discard it. But that's that's an item that that's what I can configure in the device manager. The hazard scenario editor. Let's just look at that real quickly. Let's just see if I can randomly pick one here. Loss of flame. We have a total of 4 IPLs suggested, and they are in order that they are performing. But if for whatever reason the oxygen monitoring would happen after the CIF 19-.4 would operate, then I can change that order of execution as well. Let's see. Looking if there's any questions. I got an idea there was a question, but I don't see it. Okay, that's fine. Maybe just me. All right, so that's what we can do in the hazard scenario editor, and then if we go to create procedures, this is where we would create particular proof test procedures, and we can use reuse revisions, etc. And so on. So then we go to the recording of events. So let's say I want to record a process demand. And let's say that process demand happened in this particular thermal oxidizer and this incinerator. And let's say this is the hazardous event that I'm looking at. And I can indicate which layer was successful. And by selecting the BPCS layer was successful, I'll automatically say, hey, the monitoring didn't work. Or if I say the CIF was successful, I'll automatically say, hey, these other layers weren't effective. So that's what I can, what I can do when I record a demand. If I want to record a activity, which could be a proof test, I'm going to see all the proof tests that are due for all the devices. And as I said, this is a very sparse database. I only have 2 devices with a proof test assigned to them. One was due yesterday. One is due in February of next year. If I click on the second higher level entity, you see there's another proof test that's due also February, a year from now. So there's just an overview of what is due. If I hit on my pressure transmitter, say start, I can record my my proof test. And in this case, it's just a 2-step proof test. Obviously, that would not be an adequate proof test. But let's say I have a 21.5 milliamp, and check that is complete, and a 3.75 milliamp output that I measure in these 2 locations. I can add a comment. I can also make a overall comment mandatory. So at the end of each proof test, we require that someone always types in a comment. That is something we can specify during the original specification of the proof test. And I just simply hit save, and then I've completed my proof test. Now, one of the things that you will see here is that the pressure transmitter, the proof test, is still on there, but now it has a different due date. The due date is now 2016 and not 2015, so the tool will automatically know, hey, you need to do that. So that's, and then if we go to view the events, go to our dashboard, set this back to months. Let's do 2 years. You see the 2 proof tests that are due in February of 2016 and the one that's due in March of 2016. So that will help you with any planning that you need to do. And then you see, a year after that, you see the same behavior because it's the same 2 proof tests. Everything is, at least in this example, is due every month. Sorry, every year. And then we have the overdue activities. In this case, everything has been done. There's just two proof tests. So that's one of the things that we can see in the dashboard. Then we can look at the event viewer. It will show all the events that were recorded. We can filter. We can say we only want to see proof tests. And when we do that, we see that hey, there was a proof test performed on a particular instrument. In this case, that same instrument was tested twice today because I did the webinar this morning and now. But here's your list of all your proof tests that were performed. Or if you want to see all the process demands, you can filter for that. Here are all the process demands that were executed and where they occurred and what was involved. And then you can dive into each and every one. And then here are all the procedures that were performed. And which one passed, which one failed, and so on. So that's in a nutshell the SILStat tool. Here's a question. A very good question here. Is a tool able to propose a checklist to fulfill for manual proof tests depending on the type of device? SILStat by itself will not suggest a proof test. That is really part of your conceptual design, which is what we handle in the Silver tool, which is part of the Excellencia software. And as I said before, you don't need Excellencia to use SILStat, but this type of information is what would come out of Excellencia. So we have in Excellencia we have a equipment database. Associated with that equipment database are proof test steps for each equipment item, and you can generate a proof test report for each equipment item that is part of your project. You can modify those as you see fit and then use in SILStat. But that would kind of be part of the import out of Excellencia, and not just not something that you would configure here. Now, having said that, once you get to your procedures here, so once I've created a procedure for a pressure transmitter, now I can add to this, I can change this, I can copy this procedure, I can if I have a particular transmitter in my plant, I can simply link all those transmitters to the same procedure. So I don't necessarily have to define a procedure for every single for every single device in the plant. I just need to link it to the appropriate proof tests, assuming that the proof tests are identical, are similar. So here's where you would configure your proof test, or you would create a maintenance activity, and the maintenance activities are similar as proof tests, except typically there's replace a module and so on. So I haven't set anything up in this database yet. All right. I hope that was some useful information about SILStat. I appreciate the questions. There were some very good questions here. Another question here is on what does the tool support from an enterprise level. So we have basically two options for SILStat. We have what we call SILStat Lite and SILStat Site. And when it comes to SILStat Lite, it is something that you would install on your local machine. It's not intended for a larger organization. It is really intended for small organizations that currently have nothing and want to start out with. Necessarily be internet-based, but it's intranet-based to a single database, so a single repository. You can implement that on a per-site basis. So let's say I have a refinery, and in one place, and another refinery in another place. You may say, hey, I'm going to have two separate site installations for these locations. Alternatively, you could actually set that up in such a way that it is one installation for all the locations. They all report to a central database. At that point, however, you need to make sure that your intranet connections are really solid. So if does it work with a single database across the world? Absolutely, its functionality is set up so that it can be done. But from a from a usability perspective, what we see sometimes is that internet connections aren't always that the best, and then you don't want your maintenance system to be offline. So that's so yes, it can be set up that way. Sometimes it's better to have a unique install per site just for consistency. All right. Well, thank everybody for attending. I will ask that our webinar team will distribute the presentation. The PDF file, I think, is always sent out. as well as the recording. I think it's this afternoon's recording that we will publish. I think that the questions that you guys had were very good. I appreciate that. So thanks for attending. And if there are any questions on Excellentia or on SILStat, there is a easy way to contact us. Let me show that to you as well. You can go to support.exida.com and you can open a ticket, and that ticket will help in distributing. This ticket system will help in distributing the question to the appropriate person. Sometimes when it's modeling related, it ends up on my desk. When it's really technical support, it will end up on one of our technical support people's desks. But that's a way to contact us. Or you can contact us by sending an email to info@exida.com, info@exida.com. Again, thanks for attending. I think we're going to end the recording now, and I hope this was very useful. At least one of you, sent me a couple of things, so appreciate that. Take care. Bye-bye.